Hello, today we're going to learn about law of cosine. So, like in every section, I'll give you the formulas to know before you do before we go over the law of cosine. So, here are some formulas you must know. If you already know it, you could just skip through it. So, if you don't, you could just write it down and listen. So, a squared equals only for oblique triangles, we have a squared equals b squared plus c squared minus 2b cosine alpha, 2bc cosine alpha. B squared equals a squared plus c squared minus 2ac times cosine beta, and then c squared equals a squared plus b squared minus 2ab times cosine alpha. And these are only for oblique triangles. And then we also have the Heron's area formula. So if you wanted to find the area, we could use the Heron's area. So it's basically square root of s times s minus a times s minus b times s minus c, where s equals a plus b plus c all over 2. So let's do it the first problem. So it says solves each triangle. So we are given the line segment, because notice how, so first of all, we have the triangle ABC, right? And it's really important how you draw that triangle, because where you have big A, you should have the opposite side should have a line segment of small a. So let me just review it. So this is how I know this triangle is right, because I use the law of sine. So this is a law of sines. So it's basically sine alpha over small a sine beta. This should be a review. And if you want to know more about law of sines, I have a video on that. Sine of gamma over c. So basically it's just wherever you see alpha, here's alpha, it's always the opposite side. So this is the opposite, so you have line segment of 6 of a, and then wherever there's a beta, you have a line segment of b, and then wherever there's a gamma, right here, you have a line segment of c. So that's how I know this triangle is correct. So I gotta solve. So we're missing. We don't know any angles. We don't know alpha, gamma, or beta. So, but we know we have all the sides. So I will use this formula of the law of cosine. So c squared equals a squared plus b squared minus 2ab times cosine gamma. So we know c squared, right? So c is 5.2 square, and then that equals, and then we know what a is, right? 6.1 plus, and then b is 10.3 minus 2 times ab, which is 6.1 times by b, which is 10.3, and then cosine gamma. So if we do the work on the left side, we get 27.04, and then this is 37.21 plus 106.09. And then minus 125.66 times it by cosine gamma. So I will subtract. So if you add these two, you get 143.3, and then this brings down the negative 125.66 times it by cosine gamma, and then the left side we get 27.04. So we got to solve for cosine, so I'm going to subtract 143 from both sides. 140.3. This cancels, so you're left with negative 116.26 equals negative 125.6 times it by cosine gamma. So we want to solve eventually for gamma, so first we got to get rid of this negative 125, so we're going to divide everything by 125.66. So you're left with cosine gamma equals 0.9251. And then remember how to take the we got to solve for y, right? So we got to multiply everything by cosine inverse. So if we did that, we get the cosine cancels, and then you get if you take the cosine inverse in 0.95, make sure it's in degrees, you should get 22.30 degrees, and then I'm just going to round it to 1 places, or the nearest tenths. So gamma should give you 22.3. Okay, so we found gamma, so we could put it right here. Gamma is 22.3. So we got to just find alpha and beta. So basically we just got to find one of these other angles, then then add these two and subtract it from 180. So what I will use is okay, so now I can use this formula, this law of cosine. So I'm going to use a square equals b square plus c square minus 2bc cosine alpha. So we know a is 6.1 square, and then we know our b is 10.3. Square, and then we know our c is 5.2 square. .3. It's just putting it in. C is 5.2, and then cosine alpha. So if we did all the work, we should get, this is what we should get. We should get 37.21 equals 106.09 plus 27.04 minus 107.112 times it by cosine alpha. Okay, so what I'm going to do is simplify. So 106.09 plus 27.04 is 133.13. subtract 133 from both sides. And then on the left side, you should get negative 95.92. 95.92 equals, don't forget this, negative 107.112 times it by cosine alpha. Then divide everything by negative 107.112. So you should get, on the left you should get 0.8954. Equals cosine alpha. And then you have to multiply it. We want to solve for alpha, so we have to take the cosine inverse. So if you take the cosine inverse, alpha should give you 26.4344, and then just round it to 1 decimal places, so it's just 26.4. So that is our alpha. And our gamma is 22.3. Whoops. So here's alpha. Where's alpha? Right here. 26.4. Okay, so now we got to find beta, which is really simple. All you got to do is add 26 plus. So we're going to add 26.4 plus 22.3. That should give you 48.7. And then you just do 180 minus 48.7. That should give you 131.3. So beta is 131.3. So we know all our three different angles. So beta is 131.3, gamma is 22.3, and alpha is 26.4. And I found those angles by using the law of cosine. So we go to another one. So it says solve each triangle with the given information. So we're given line segment A equals 18.5 and line segment B is 12.2 and line segment C is 8.1. Like I said, it's really important how you draw the triangle, because we know that, so we know this is triangle ABC, so we know that A has alphas and the opposite is A, and the same with gamma. So gamma goes with C, so that's why we have C over here, and then beta goes with small b, so that's how we got this. Okay, so what do we want? We want to find, we gotta find alpha, gamma, and beta. Wait. Yeah, we gotta find three different angles. So we're giving side, side, side. So I'll use this law of cosine. So b squared equals a squared plus c squared minus 2ac times by cosine beta. So we just put it in. We know what b is 12.2. We know what a is 18.5. And we know what c is 8.1. I'm just putting it in the formula. Cosine beta So if we do all the work, we get, on the left side, we get 148.84. This is 342.25 plus 65.61 minus 299.7 cosine beta. So add these two, 342 plus 665 is 407. 407.86 minus 299.2. And then subtract this. So this, on the left side, you get negative 259.02 equals negative 299.7 times by cosine beta, and then you divide everything by negative 299.7. So cosine beta is 0.8642, 0.8642, and then if you just multiply everything by cosine inverse, you should get beta equals 30.201, and then just round it to one decimal place, so it's 30.2. So this is our beta. So beta is 30.2. Now let's find gamma. We just gotta find gamma or alpha. So I'm gonna find gamma. So let's go on the left. So I'm gonna use this formula, c squared. This is the law of cosine, remember, a squared plus b squared minus 2ab cosine gamma. So we know that c is 8.1. And we know a is 18.5. And we know b is 12.2. Minus 2ab 12.2, and then cosine gamma. So, okay, so if we do the work, we get 65.61 on the left side, and then right we get 342.25 plus 148.84. Minus 451.4. If you add those two, you get 491.01 minus 451 cosine gamma. This is 65.61 minus 491.09 minus 491.09. So this is, on the left side we get negative 425.48 equals negative 451.4. Yeah, this is a 0.4. So it's negative 451.4 cosine gamma. So divide everything by negative 451. So we get cosine gamma equals 0.942. And then if you take the cosine inverse of everything, remember, make sure it's degrees because you'll get something else. You should get 19.5. Well, it's 19.510, but I just rounded it. So here's gamma, so this is 19.5. Now we could just find gamma by adding those two and subtracting 180. So we know that, let's put it in. So we know that 19.5 plus 19.5 plus 30.2. If you add those two, you should get hold on, let me get my calculator. So if you add 19.5 plus 30.2, you get 49.7. And then basically you just subtract 180 minus 49.7. So gamma is minus 49.7, 130.3. So that's gamma. Good. Let's do another one. Okay, this one's different. We have solve each triangle with the given information. We know, so length segment A is equal to 7.2, beta is 25 degrees, and gamma is 35 degrees. So we have a side, angle, angle. So first I will use, just let me, yes, so first what I could do is I could find alpha really quick. We know I could find alpha, right, because we have two angles, 35 and 25 degrees. So let's find alpha. So you just got to add 35 plus 25 equals 60. And then what you do is 180 minus 60 is 120. So this is alpha. Now let's find, we gotta find B and C, so I cannot use the law of cosine for this because we have side, angle, angle, so I'm gonna use the law of sine because none of the law of cosine will work. So I'm gonna use sine of 120. So where did we get 120? So we got 120 from here, so it goes with A, which is 7.2. And then I'm going to use sine of 25. So here's 25, and that goes with B. So cross multiply, you get B sine of 120 and then 7.2 sine of 25. So divide everything by sine of 120. (7.2 sine of 25) sine of 120. So B is B should give you 3.13, so we'll round it to one place. So it's just 3.5. Let's find C. I don't use the Pythagorean theorem to find C. It won't work. We still got to use the law of sine. So I will use sine of 120. 120, I get that here. We get from alpha, so it goes with A. So 7.2 equals sine of 35, or 35 right here. And I get that from C. And then just cross multiply. So that's 7.2 sine of 35. Let's solve for C by dividing everything by sine of 120. So C is 4.768. And I'll round it to one decimal, so it's 4.8. Good, so we found our B, our C, and then we found our alpha by using the law of sine. Let's do this one. So given A equals 8.2 and B equals 3.7, C equals 10.8, solve the triangle. So we're given side, side, side. So we could use the law of cosine for this one. Well, I just want to clarify that this is triangle ABC. So this is A, B, C, because A is alpha and it goes with A, and C is gamma and goes with little c, and then B is beta, which goes with small b. So here's c squared. I'll use this law of cosine. C squared equals a squared plus b squared minus 2ab cosine gamma. Same, just gotta plug it in, so we know C is 10.8 equals, and we know A is 8.2, and we know B is 3.7 minus 2, and then A is 8.2, and then B is, where's B? B is 3.7 times it by cosine gamma. Do the work. You should get, on the left side, you should get 116.64. We get, on the right, we get 67.24 plus 13.69 minus 60.68. Cosine gamma, plop. More work, so let's simplify. Those two equals, if you add 67 and 13, you get 80.93 minus 60.68 cosine gamma. So this is 16.64. Subtract this, both sides. So the left side you get 35.7 equals negative 60.68 cosine gamma. Divide everything by negative 60.68. So this is negative 0.588. Negative 0.588 equals cosine gamma. Gamma is 126.1. Where's gamma? Right here. 126.1. So we just gotta find beta and gamma. Okay, now I can use the law of cosine. So I will use law of sine, not cosine. So I'm going to use sine of 126.1. So where do I get 120? 126 is from gamma. So that goes with C, which is 10.8, equals sine of beta sine of B is, it goes with small b, so it's 3.7. If we were to cross multiply, put it here, we get 3.7 sine of 126.1 equals sine of 10.8 sine of b. So sine of beta is 0.2768. So we gotta find b, so take the sine inverse of both sides, and you should get 161.1. So we found b, we found alpha, let's find gamma. Let's find alpha. So you just add those two, so 161.1 plus 126.1 equals 142.2, and then 180 minus 142.2 is 37.8. So alpha is 37.8. Where's alpha? Right here. This is 37.8. Good, so we know our alpha, we know our gamma, we know our beta, and how I found it, I used one law of cosine, and then the second one I used law of sine. Okay, so it says find the area of each triangle using Heron's formula. This is really simple. We just gotta figure it out. So just gotta plug it in the formula. So area equals. So let's find S. So S equals A plus B plus C. So that's 3, 4, 6 plus 2, 3, 4 plus 4, 2, 2 divided by 2. That equals 501. So it's 501 times by 501 minus A, which is 346, times 501 minus 234, and then 501 minus 422. Okay, so if you do all the work, you should get square root of 6915. And if you take the square root of that, you should get 40471.927, and area equals 47.9. So this is our final answer. It's 40471.9. That's the area. Okay, next one. So now we're going to do word problems. So it says a central angle alpha is in a circle of radius r, intercepts a chord of length a. Write a formula for a in terms of alpha and radius. So here's the diagram. So here's a circle, and then here's a triangle. So this is angle alpha. This is line segment A, and this is radius. So I will use law of cosine. So it's a squared equals r squared plus r squared minus 2r squared cosine alpha. Oops, that looks like it's alpha, not gamma. So if let's simplify. Let's simplify. Look here. We could take out an r, right? I could factor out an r squared. So that's 1 plus 1 minus 2 cosine alpha. And if you simplify that even more, that's r squared times by 2 minus 2 cosine alpha. Equals a squared. And then let's take the square root of both sides. So a equals r 2 minus 2 cosine alpha. And I will only use positive. Yeah, there we go. For this one, it's a word. Let me read out the problem. So it says a robotic arm with a 0.5 meter segment and a 0.3 meter segment is attached to the origin as shown in figure 7.19. The computer-controlled arm is positioned by rotating each segment through angles theta 1 and theta 2. As shown, given that what we have the end of the arm at the point 0.7, coordinates of 0.7, 0.2, we got to find theta and theta 1 and theta 2 to the nearest tenth of a degree. So right here, this is the robotic arm. I know this is really bad. So this is the robotic arm. So we got to find theta 1. Here's theta 1 and theta 2. So the first step, I'm going to find omega. So omega is right here. So omega equals tangent inverse. So omega is y over x, right? So this this is the x and this is the y. So it's 0.2 over 0.7. That's, if you do the calculator, put it in the calculator, it's about 15.95. So okay, so now we found omega. Now I want a more accurate angle, so I want it to the nearest tenth, and I'll be using it by using the Pythagorean theorem. So let's use b equals 0.7 square plus 0.2 square, and that should give you approximately 0.73. It says now I need to find b by using the law of cosine. So we got to find b by using the law of cosine. So I'm going to use this law of cosine. So I'm going to use b squared equals a squared plus c squared minus 2ac times by cosine beta. So we know that b is 0.73 square equals 0.5 square plus 0.3 square minus 0.5 times 0.3 times by cosine beta. Okay, so if I do all the work and I solve for b, right, you know how to do it, because beta should give you 130.02 degrees. So I rounded to nearest to 2 decimal places. Okay, I'm going to go to the next page because I need more space. Oh, I can't. Let me clear this. Okay, so now for finding alpha, where's alpha? We got to find this alpha, this angle alpha. For finding, I will use the law of sine. Use law of sines. So sine of alpha is 0.3 equals sine of 130.02 divided by 0.73. Cross multiply, so that gives me 0.73 sine of alpha equals 0.3 sine of 130.02. Divide everything by 0.73. So sine of alpha is 0.3147. Take the sine and multiply the sine of inverse on both sides, so you get alpha equals 18.34 degrees. So the goal, what do we need to find? We gotta find alpha 1 and alpha 2. So we gotta find these two angles, right? So alpha 1 is basically 90 degrees minus alpha and minus omega. So that is 90 minus 18.34 minus 15.95. That is 55.7. Good. Now we gotta find alpha 2. Right? So since beta and theta and theta 2 are supplementary, meaning their angles added up to 180. That's what supplementary means. Yeah, so if they say something supplementary, those two angles should be 180. If something is complementary, those two angles should be added to 90. So I'll put here theta 2 equals 180 minus 130.02. So that gives us 49.98. So our first theta 1 is 55. So 55.71 degrees, and theta 2 is 49. So we found everything. We found theta 1, theta 2 by finding alpha and omega. And that's it for this section.